Now, at our fourth and the last paper for the session, this paper is by Major RMIN Bandara and Dr. T.L. Weerawardane, and I don't think I need to introduce them again. We have already introduced them. The paper is Interaction of Electromagnetic Radiation Emitted from Mobile Phones and the Human Brain Tissues. And the presentation will be done by Major Bandara.
So, good morning again. I will say good morning, ladies and gentlemen. So, don't think that I am totally against of this mobile communication. In my first paper, I said that mobile jammer. Now, I am going to tell you what are the effect of this mobile phone usage, biological effect. So, don't think that I am against this mobile communication, because even everyone is addicted to mobile phone usages. So, I am also same. We cannot spend one day without mobile phone, right? In my topic that I divided into these subtopics as shown on the screen. When I started this research, I had two questions arise. First one is, what are the effects of radio waves on human health? Then, what are the health risks that is associated with use of cell phone, mobile radios, microwave ovens, broadcast radios, television transmitters, power lines, and X-rays? If we look at this electromagnetic spectrum, I am not going to tell you what is it, but mainly this electromagnetic spectrum can be divided into two parts. One is that non-ionization radiation, and other one is ionization radiation. From low frequencies up to microwave range, it is non-ionization radiation. Beyond that, it is ionization radiation. We will look at what is the meaning of this. Ionization radiation. Electronic magnetic energy is carried by photons. The higher frequency, the higher energy in each photon. Ionization radiation is radiation with enough energy. So during an interaction with an atom, it can remove tightly bound electrons from the orbit of an atom and causing atom become a charged or ionized. The best thing is the skin burns due to the sun, this ultraviolet. So, then when we are talking about the non-ionization radiation is lower part of the frequency spectrum. So the main effect of this is heat generation. Something like how this in the microwave oven, how the way of something that cooked. When we are coming on to this, mainly my topic is we are concentrate on to this non-ionization radiation. The biological effects from non-ionization radiation exposure will be depend on mainly the energy of the interaction radiation, that output of the energies mean that output voltages, then the power density of the field or the beam, then source emission characteristics, duration of expose, environmental condition, and the way of the equipment we are orientated, and the biological characteristics of irradiated tissues. Mainly these biological effects of this non-ionization radiation, I said that it is mainly thermal effect. If we talk about our body, the most vulnerable place is our eye. Because if we talk about our brain has some kind of protection from the skull, but our eyes is totally naked. Another thing is the amount of blood vessels going through the eyes. It is minimal comparing with others. Because of that reason, the heat generated inside this is not efficiently dissipated like other. Okay. Then I am talking about this heat or the thermal effect. So actually what is the effect of this? According to the research, it is found out that if we talk about one cell, the temperature of this cell increased by 1 centigrade, and it will doing that continuously in a long time period. As a result, the internal characteristics of this cell will be changed. What will the ultimate result of this? Cancer. Right. So, in some of this research done in Australia and Canada, they get some random amount of people and their living conditions or the living environment, and they did this nearly 20 to 25 years. They found that nearly more than 85 to 90% probability is there for getting onto the cancers. When I am talking about this heat, I have to measure the heat or the thermal effect of this. For that, there are 3 numerical methods are there. One is that momentum method of momentum, then the finite element method. The method that I used is finite difference time domain method. I'll just give just an introduction on this. In normal calculus, everyone that we know, this is the simple thing. If we take about the forward difference expression, just amount of this, I am not going to brief you this because everyone is knowing this. This is the simple theory behind this finite difference time domain method. So, for this, there is an algorithm called E algorithm. In this is the E lattice. I'll just explain in next slide. If we talk about here, remember this, I am talking on the 3D nature. I am not talking about the XY. I am talking about the XY is a 3D nature because we are in the 3D, right? We cannot say in the single 2D plane. If we talk about a single location in this one location, one incident or the one electronic or magnet, here is this electric field and H is the magnetic field. If we consider one location, if we say that it is a magnetic field, so it is covered with these 4 electric fields. And same day, if we consider one electric field, it is covered with the 4 electric fields of this. Because electromagnetic radiation is going on this electric and variation of this electric and magnetic fields. So, from that, I derive this equation from this, how this in X, Y and is a 3D plane, this radiation is how it is propagating. From that, then I have to calculate this. For that, I have to make a computational model for this. For that, I use for this language I use is this Visual Studio Visual Basic. For that, I use 3D array. In a 3D array, I change the previous equation onto this, and after that, I get the results of this. So from that I am measuring the electric field strength on a particular incident. From that I measure the SAR or specific absorption rate. This is the ultimate requirement of that previous study. What is this specific absorption rate? It is defined by the time derivatives of incremental energy absorbed by an incremental mass contained in a volume element. So, we can find out the specific absorption rate from this equation. For that, I require conductivity of the tissue and mass density and electric field strength. Previous values, I can find out the RMS value of electric field accordingly. So, this specific absorption rate also depends on some factors. One is geometry of the part of the body, then the exact location, geometry of the source of RF energy, and the incident field parameters and ground and reflective effects. These are the conductivity and the relative permittivity in different part of. Here, mainly I consider about the brain. So, in the brain, grey matters, white matters, cerebrium, then the skin. In the skin also, it depending according to the frequency, these dielectric properties. For the dry skin and the wet skin, it is different. And the brain, skull, and the muscles. Likewise, these are the parameters of it.